Yeah, go ahead.
Hi, good evening. Hi. Hi everyone. I'm Devon. I'm from CS Tutoring Club here in Davis, and I just wanted to announce that our tutoring services have just opened up, and there's lots of 36B tutors who are waiting to help you. So if you want more information or ever need help, just go to our Instagram, and there's a link tree that will lead you to our Discord. And from there, it's pretty easy to get tutoring. You just click on the channel the class that you want, and it'll show if there are tutors available. And if you want to check when tutors are available, there's a Google Calendar link that you can click to see when our tutors are available. And yeah, they'll be able to help you succeed in this class. So thank you, everyone. Have a great spring quarter. Thank you.
Thank you. Thank you so much. Of course. Okay, so this has been recorded. So if you want to find more information, thank you very much for providing this very, very valuable resources for not just ecs36b, but for all the classes in computer science. Okay, a few logistic things I want to start it before. Okay, I have already made up the homework assignment number 2, which I will be start talking about this. Again, this has 2 parts. One part is actually 0%. So it means this part does not really, you don't need to turn in anything, but this part is important for you to be able to do some kind of installation about some of the package. Especially, we want you to install 2 packages. One is called JSON CPP, which is the C++ library for JSON. Some of you might already have this installed. So just checking, make sure you have that. There's a test program over here to verify whether you have a successful installation. And the other thing, which is kind of unlikely that you already have this installed, is called JSON RPC CPP. This is essentially allow you to do web programming using C++, which is a very useful library to do a lot of things. I'd like you to have both this installed. The other thing, very important, this homework assignment is a team project. So remember, for the final project, we're going to have a team. So by default, it's 2 students a team, right? So if you have trouble finding a partner, let me know. But either this Thursday or next Tuesday, I'm going to do some kind of, I call it a team sign-up party, which please bring your computer. If you don't have your computer, then you have to use my computer or somebody else's computer to sign up. We will have some activity tell you how to do that, okay? But it's probably not going to be this Thursday because in order to do the sign-up party, you need to have the JSON RPC CPP installed, because what you essentially need to do is you need to talk to the sign-up server with the web programming concept using C++. Okay, so this is a team project. The first part is for you to just get the environment set up for you to do the rest of the work. And the part 2, I just want to tell you very briefly, I'm going to spend more time. By the way, everything here is just tell you how you're going to verify whether your installation is correct or not. Okay, I will talk to the TA, make sure that they will give you help, give you more time to ask questions when you go through that process. So here's a real homework assignment number 2. Okay, it's pretty short. Okay, so what it does is a program, again, just like homework assignment number 1. So homework assignment number 1, essentially after the, let me highlight this so you know what I'm talking about here. So I'm talking about this particular line. So for homework assignment number 1, what you need to do is you have a command called ecs36b part 2, and then you have 4 arguments, which represent 2 pairs of longitude and latitude. And then your program is going to calculate the distance about that pair of GPS location. So over here is still a program called HW2 part 2, and follow that, there are two arguments you need to provide. So the first argument is essentially, I call it location and time.json, which is a file, but the file itself is with JSON format, which I will show you example right below. And the second one is what I call a question.json. So let me tell you the high level this program is going to do. So essentially, you think about I, as a person, I'm wearing my device or whatever. This device is keep tracking at which time moment where I am. So essentially, you think about, I want to track where did I go today. So essentially, there are two pieces of information that's important. One is the GPS location, latitude, longitude, and then the time moment I was at that particular GPS location. So you think about each one of us, regardless is yourself or your device, it's essentially a sequence, an older sequence of GPS and the time stamp. So this actually gives you a really nice tracking about where you are the whole time, okay? This is a very useful service. Google has been doing that all the time, by the way. They use this to track the speed, how fast you drive, to actually evaluate how congested a particular section of highway is. Okay, so that's a very basic fundamental. So the first file is basically say, hey, you gave me a sequence, an older sequence of GPS location and timestamp, a sequence of that. And then the second argument, question.json, is essentially just a timestamp because the question is saying that where you are at this particular time. If you think about the first one, if you have all the location and time pair for tracking where you are, and then I ask where you are, the police department want to ask you whether you're involved in some complicated situation. They want to show you whether you have an alibi for something. You say, okay, where are you at 10 p.m. last night? And then you essentially look at that first file. You say, okay, this is the location I am. Okay, so you can use this as a alibi service. So let me recap what you're supposed to. Your program is taking input of the sequence of GPS and time, and then your program will take the second input as a question, as a timestamp, and then you need to answer a location about where you are. Okay, so that's the base. So here's an example. I mean, I'm kind of make a very simple example. Of course, it has to be more complicated than that, more than two. But assuming I don't have a two. Okay, so just give you an idea. If you see a bracket, if I call a JSON format, if you see a bracket like here and here, this means that this is an array in JSON specification, meaning that you have a bunch of elements that's construct array. Okay, so if you see a bracket, that's a represent array. If you see a curly bracket, that represent is an object. Okay, later you will see that why these two things are so useful when you want to represent a C++ object internally. But now let's just learn. If you see a bracket, you know that it is an array. So this array has two elements. The first element is this part. And the second element is this part. Okay, so let's take a look just the first element because then you will see how you read the second element. So this is the first element without the first bracket. Sorry, I didn't highlight exactly what I want to highlight. So if you look at this element, what I want to do is I want to copy this. I want to use my PowerPoint to represent that. I don't need you. Okay, I'm going to do this. Okay, this is the element I just copied. Can I make it a little bit smaller? Sorry. Okay, I hope you can still see it, but I want to get rid of this one. Okay, so this is the one single element. If I get rid of the comma, this might be even better. Let me just make it slightly bigger. Hopefully, it will still allow me to do that. Seriously? Okay, good. I have exactly fit into my slide. Okay, this is the one element. And I do want to say, let's try to parse it. This element is started with a bracket and ended with a bracket. Okay, curly bracket. No, not bracket, curly bracket. This is very important, the difference. Okay, so I'm going to cut it off so you know that this is just a representation. By the way, did I just say if anything contained within a bracket that's internally we call is a JSON object. But at this moment, you don't need to know what exactly JSON object is, but you know it's a separation from a set of elements. And then within this element, you actually see two parts separated by the comma. Let me actually make it two lines so you can see I actually have this two element. So the first element, I call it GPS DD, which is represent a GPS location. And then I have the second element, which is time. That's what I said earlier. So each of the elements in the array, each of the element has GPS location and the corresponding time stamp. Okay, so there are two elements. And what is a JSON? JSON is really what we call key value pair separated by a column. So this is the key. I have a two key here. This is the key. GPS DD is a key. And then time is a key as well. And then separate by column. And then here's the value. So this is the value corresponding to the key. And you can see that this value itself is an object because it's separated by the curly bracket. And then inside the bracket, it has two key value pair. The first key value pair is a latitude 1.0, whatever value is. And then the second is a longitude with whatever value it is. Okay, so I'm actually using this representation to understand what is a JSON representation about a GPS location. If you actually remember what we did for homework 1 or whatever, we talked about GPS.h, that key value pair structure, latitude and longitude, that match exactly the member or attribute of the class GPSDD. Okay, so this is really an internal representation about your object, but just using the JSON format. But okay, so the first element is a GPS and then the value, and the second element is a time and the timestamp. The timestamp is like this. This is the standard format for us to represent the time all the way to the seconds. Yeah.
Are you creating new objects?
It's up to you. Okay, see, that's the thing. What I only specify, that's a good question, but I don't want to mandate how you're going to do this internally. But I want to do the interface between how I'm going to evaluate your program and how you're going to do it is essentially by this interface. I'm actually going to give you this as an input, which is a sequence of the GPS and the timestamp following the format I show you. And then I'm going to give you the second file about the question. I want to say, okay, I want to see where you are at this particular time. And then you're going to tell me what is a GPS location. So let's actually go back to this example a little bit. So as long as I give you this two, you give me back the correct time in the JSON format, your program is correct. I mean, you don't have to create any class, that might be fine, but it might not be the best things for you to do. in my opinion, there is a lot of class already included in the master directory. You can try to pull in and use it. And also, the other thing very important, now you see that the input is JSON, output is JSON. So for homework assignment number one, I said, well, you can do whatever, just print a string in JSON format. For homework assignment number two, it's important you use JSON CPP. Why I said JSON CPP? Because JSON CPP is a library for you to directly read the file in the JSON format into something which is very easy. You can parse, you can do some. I mean, by the way, I'm going to teach you how to do some of the JSON programming in class as well. Okay, but just let you know, that's what the interface for the program. So let me actually go through this example a little bit. So for example, this two has only two timestamps. One timestamp is the last night, 11 o'clock, 59:59. Okay, that's last night, right? Yeah, that's last night because that was the deadline for me to submit my federal tax. Okay, I hope you guys all did that. Okay, I'm kind of usually wait for the last minute. Okay, anyway, so that was the first timestamp. I was in this particular location. And then about 2 a.m., okay, if you look at this timestamp, 2 a.m. this morning, I was in a different location, right? So that's the two timestamp represent. I was here at 11:59:59, and then I was here at 2 a.m. So now the question is where I was, sorry, at this time. If you think about that, this is a 30 minutes past midnight where I was, right? The police officer is trying to do some kind of manhunting, and then I'm the suspect, because I assigned the homework for ecs36 too difficult, and the police is not happy about that. Okay, so they're asking me where I was, sorry. And then the thing is that because if you compare the two timestamps, it's actually the time that was asked was in between, right? Was just in between those two timestamps. So my location should be in the first location. Okay, by the way, when you write program, you're going to compare two timestamps. We have a lot of operator overloadings for you to do. You can do operator overloading on two timestamps, greater than or smaller than. Then you can quickly find out where that is. Okay, so it might sound complicated, but it gives you a chance to use a lot of different classes, or you want to write everything from scratch, that's perfectly okay. Okay, I hope you can start working on this based on whatever information. We'll start talking about some of the issue. By the way, this is the way I feel is more maybe I would say more efficient for you to learn, is that usually you start to solve this problem. And then you realize that, okay, I'm actually encountered this. I have no idea how do I do this? How do I, for example, homework assignment number one, I feel the number one issue is, well, how do I handle ARGV, ARGC, that kind of thing, okay? And the thing is that when you encounter this issue, bring it to my office hour, or even bring it to the class, that's fine. Bring it to discussion session, and then I'll adjust my lecture such that I will address your issue, such that when we use this time, I'm actually helping. You're not just helping yourself. When one of the students asks the question, my experience, it really, really helps a much bigger number of students in class as well. Okay, so that's homework assignment number two is out. Pretty much the rest is the same. Submission is the same. You should have just all the .cpp file, .h file. Remember, you have a make file and your README file. Just make sure you have all the student ID, name, and the email address for all the team member. Most of the things should be 2 students. I'm expecting a couple team might have 3 students because they cannot find anybody else to work with at the end. Okay. Okay. Any question? All right. Okay, I'm going to first talk about the next topic, and then I will do more logistics. So, okay, we're going to talk about chapter 13 and 14 kind of together because both of them are related to inheritance. So chapter 13 is about basic inheritance. And chapter 14 is a more like advanced version of inheritance, which we call it polymorphism. I mean, how do you use inheritance to realize the concept of polymorphism? Okay, so these are the two chapters we're going to cover right now. Okay, so first, let's talk about what is inheritance. So inheritance is, I will call it is, sometimes I just say is a relationship. Is a relationship. So what is a relationship? So it's a relationship defined between a pair of classes. One of the class is called base class. One of the class is called derived class. So essentially, when I say is a relationship, means that an object that's actually from the derived class is a base class. Or sometimes we don't call it base class and derived class. Sometimes we call it parent class and child class, okay? I mean, there are multiple terminology you can describe this inheritance relationship. So in this case, a child is a parent, okay? Meaning that it doesn't say a child has to be a parent. It means that whatever the property of the parent, that the child has that. Okay, so in this case, this is a very simple example from your textbook that the base class is a box and the derived class is a carton. So which means that a carton, which is the derived class, is also considered a box because it has all the property that belong to the box. So let's try to see, okay, this is a relationship, or you can say carton is a box. Okay, so let's use the example to see how this can be specified. This relationship can be specified in a programming language like C++. So if you think about, here is definition of a box. This is the definition of a box. So just forget about protected and public right now, okay? I'm not going to cover the difference between protected and private at this moment. We'll probably do it at the end of this lecture. But if you look at the box is essentially a class with a bunch of attributes. So it has three attributes, length, width, and height. It has a three attribute, and it has a bunch of member functions such as constructor. It has a bunch of member functions such as get length, get width, and things like that. The usual suspect, you see that. Okay, so that is defined, the base class. Okay, here's the inheritance syntax. Is that now I want to define another class called carton, which carton should be inheriting from box. And the way to do it is say class carton colon. And here I have a keyword public, but I'm not going to differentiate because potentially you can put public, you can put protected, you can put private here as well. But right now, let's just do public. That's the easiest one. Just want to tell you later, I'll tell you that what's the difference you can make here. But essentially, you put a colon and then put the parent class. So essentially, when you have this line, class, carton, colon, box, you have defined a relationship saying that carton is going to inherit everything from the class box. And then the carton has its own private variable, is attribute called material. And so essentially then you have a bunch of other member function, including constructor, and maybe you have other member function. In this case, you don't have any member function. You do have, I'm sorry. That's dangerous. Still work? Okay, good. Okay. All right. So by having this set up, then essentially the carton immediately has 4 attributes. It not only have this material, but it also has the length, width, and height. Okay, so you can think about by using inheritance, you kind of extend a base class, adding some new feature or attribute such that you have a new class called carton. Okay, so that's this kind of extension is very useful for us to pick a class and try to extend it to make sure the new class or new object fit your need. All right. Any question about this basic concept about inheritance? So what I did is, what is inheritance? Oh, by the way, this is called single inheritance. Single inheritance means that you have one single base class. And multiple inheritance, you have multiple parents or multiple base class. You kind of inherit, for example, I might inherit as I myself, I might be a member, a resident of Davis. I'm a faculty member of UC Davis. I'm also an employee of UC Davis, or I might be some other role. So essentially, I'm inheriting from multiple base class. That's called multiple inheritance. So at this moment, just tell you that, okay, this is getting harder, but just I have to reiterate this statement again and again. Different programming language, they have a different design of multiple inheritance. So for example, C++, we really have 3 different types of inheritance. Single inheritance, multiple inheritance, and virtual inheritance. And then in Java, they only have 2. They have a single inheritance and multiple inheritance. But their multiple inheritance is equivalent to the virtual inheritance in C++. Okay, you see that? It's already start confusing, right? If a Java programmer said multiple inheritance, talking to a C++ programmer, multiple inheritance, they're actually different. So it's really Java multiple inheritance is the same as C++ virtual inheritance, which we will talk about the difference between virtual inheritance and multiple inheritance maybe next week. I don't think I can cover that this week. It's a really, really interesting topic. Okay, so, but for most part, we should focus on single inheritance. Not only that, I do want to say that as a programmer as an object-oriented program, by the way, the first object-oriented programming I wrote was 1987. So I wrote a lot of object-oriented program. I hardly ever either need to or wanted to use multiple inheritance. I always use a single inheritance. And I hope next few lecture, I will convince you that why I make that choice. I mean, you don't have to make the same choice, but single inheritance is really clean and achieve most of the things I want to do, and without getting into the trouble, complication about multiple inheritance. Because when you roll multiple inheritance, your code become much, much harder to maintain, to change, to do something. Okay, so that's just give you a heads up about, so that's why I said, if you learn nothing about multiple inheritance, it's probably okay for your career. Okay, just make sure you learn really well about single inheritance. All right, which is already very hard, by the way. Okay, and the second things I talk about is the way to specify inheritance. Now you see that I just say, okay, whenever you have a class, and then you have a column and put your base class. Now you have a new class called carton in this example. Okay. Any question about my, yes.
Does carton still inherit like the function from box, like all you get like it would?
Yes. Yeah, you inherit everything. Yeah. Function and everything. Yeah. Okay. Yes. Mm-hmm. It will automatically. It's a recursion. Yeah. It's a transitive. So meaning that if I have, oh, that's good. Okay, I'm going to show you an example right now. So you see that what's going on. So by the way, I forgot to do this. I'm going to release to you all the sample midterm. And last quarter for 2023, I have a 5 midterm. So you guys are lucky. You only have a 1 midterm. They had a 5 midterm. Okay, don't ask me why, but okay. But this was midterm number 3. Okay, was midterm. I'm going to release you all 5 of them. So you see that I kind of have every 2 weeks. I ask the student to do a midterm. I mean, basically every quarter I teach ecs36. I try different things. So whatever I'm trying for you guys, that's also first time. Okay, so just but the content should be the same. So in this particular midterm, I actually gave them this inheritance question. Okay, that's related to what you're asking. So I have 3 class. So the base class is called MT3 thing, which is it's a 3 thing. It's a thing. Okay, and then I essentially has one derived class which I call a locatable. Locatable is a thing. And then I have another class called holdable. So holdable is a locatable. So I have a 3 class. They form the relationship thing, locatable, and holdable. So what's the member? For example, in the original thing, it just defines the sequence number about that thing. It has nothing but just of course it has constructor, has some function, but it's really the attribute only have sequence number. And then locatable has one extra attribute, which is the GPS location. So I make the thing become trackable, pretty much like what you're doing over assignment number 2. I want to make that thing trackable, so I will be able to find out when and where it was. Okay, so I have a thing and then locatable, and then I have a holdable. Holdable means that is holding by a person. Say I have a phone. Okay, right now this phone is holdable, means that I can associate a person. It seems to me. Hold on. Did I break it? Running out of it. Okay. Okay, good. Okay, and then the holdable means that okay, it has the identity or the object pointer to the person or to whatever group that's actually holding that particular object. So you can see that I have this inheritance hierarchy, which is from thing to locatable to holdable. And essentially what I need to do, just look at holdable, go back to your question, look at the holdable MT3, holdable, this is locatable, locatable. Okay, this is holdable. You can see that in the holdable, I just say class holdable, column public locatable. Okay, I only need to say who is my immediate base class or parent. And then, and this will essentially include this part, which is locatable, and the locatable, which is go to MT3 thing, okay, in the programming. And you can see that the attribute in the locatable is GPSDD is a location, and the locatable, sorry, not locatable, holdable is an attribute is a person, okay? And then the thing is the first one, the thing is just have the sequence number, okay? So that's essentially a inheritance hierarchy involve 3 elements. Okay. Any question? I will send this to you, this file, both as a sample midterm, but also I will show you what I'm talking about here as a inheritance relation with all the code available. Yeah. Okay, this is good. All right. Okay, so now I'm actually go back to this picture. So now you have the idea about how you can specify a relationship between the derived class and the base class. Yeah.
Oh, I was just wondering if if a function can be child class could overwrite a function.
Okay, good question. So let me repeat the question. The question saying that, well, the parent, when I inherit a lot of function from the parent, but then how do I override, right? Because I want to change the behavior of the parent. That's actually very expected. Sometimes I feel I'm inherit from the wrong parent. I want to change that. That's a very important topic. I will talk about that after I finish this. Okay, good. No, that's a topic, excellent topic I want to discuss. All right, thank you. All right, so before I talk about a regular function, I want to talk about constructor a little bit. So in the inheritance, the constructor, if you think about constructor, what is a constructor? Constructor is really doing initialization, right? It's really try to initialize whatever the object. So when you have a constructor, now you have how many constructor? You have multiple constructor, because if you think about, oh, now I want to go back to my previous one. So in this picture, I actually have a 3 constructor. One constructor in the MT3 thing, one constructor in the locatable, one constructor in the holdable, right? I have a 3 constructor, and they all need to initialize different things. And some of them need to initialize the sequence number, some of them need to initialize the location, some of them need to initialize the person which is holding this, right? So I have a 3 constructor. So I want to ask you the first question. I hope you can help me. If I have a 3 constructor, that means I have a 3 function. So when I create an object called holdable, I'm supposed to call all 3 constructor. Now I want to ask you which constructor to call first. Which constructor should I call first if I have a 3 constructor? Does that matter? Okay, the ideal way is always SQ the constructor from the top. So single inheritance, multiple inheritance, I'm not going to touch that right now, but single inheritance, I always call the constructor to initialize the thing first. And then I call the constructor locatable. Then I call the constructor holdable. In fact, in the execution, it's almost like a recursive. So what you will see what I do is I try to call the constructor of the class that I try to create an object. So when I call the constructor, I find is a relationship. So I will follow that is a relationship and try to call the constructor of locatable. But then I realized locatable still is a derived class of somebody else. Then I will recursively go up to thing. And in that case, I'm actually going to try to call MT3 things constructor. And then at that stage, I realized MT3 thing is the root of all the classes. So meaning that it doesn't have any base class above that. So now I can actually call MT3 things constructor. And then it will after it finish, then it will finish the locatable constructor. Finally, we'll finish the holdable constructor. That's the conceptually how the constructor will work across inheritance relationship. Well, but each of the constructors sometimes has parameter. So we have to actually see how the parameter is actually going to be passing from this class. So now I want to go back to this example. The interesting example is over here. Okay, so now let's actually look at this two classes example. I mean, if you understand 2 classes, you will be understand multiple classes as well. So let's actually look at the constructor of box, which is the parent class. And the parent class has a constructor over here. Let's actually use this because in this example, this is the here is a constructor. Here is a constructor for box. And how many arguments this constructor takes? 3, right? This constructor take this line, follow that red box, has a 3 argument. The first argument is length, which I call LV. LV stands for length variable, length value, maybe I call it LV. Second one is WV, which is the width, and the third one is HV, which is the height. So that constructor take 3 arguments to initialize a box, correct? Okay, so what does that mean? Means that in order to call the box constructor, you have to provide 3 arguments. So there is a transition from the child class to the parent class to pass that 3 value. Okay, so this gets messy a little bit. So when I create a constructor for carton, that's actually will invoke that constructor in the base class. I actually need to have a 4 argument. You see that I have a 4 argument. The first argument is LV, WV, HV. Essentially, the first 3 argument is corresponding to the 3 argument that the parent class really need. Okay, and the 4th argument is something which is belong to this particular derived class. And now this is a syntax. In order for me to transition the control to the constructor of my base class with the right argument, I actually see this after you define carton. So this line is what? The function call for the constructor at the derived class, which is carton. And here is the body of the constructor, which is essentially set up some value here. And then I actually call the box. You see that? I call box, and then I put LV, WV, HV. I put the 3 as a bracket initialization such that this will match the red box constructor above. Okay, that's how, if you want to do the inheritance, is not only say you want the inheriting, but the thing is you have to consider how do you define your constructor such that it can smoothly connect to the one of the constructor in the base class. In this case, I'm actually connected to the red one, which is with this. And then with common, this is the material, DESC. This is what we call also a bracket initialization because material is a attribute. And then I just basically put the DESC. The DESC, I got it from here. So I actually be able to initialize all the value. So just repeat, this part is initialize my base class. And this part is initialize my cell. And together, that's how you can initialize a derived class, okay? And pretty much the order looks like this. Is going over here and then going over here, okay? Any question? Yeah.
So in this case, you're creating an object called carton and then initializing the base class box from that?
Yes, yes. You try to create, this is a class, right? But this is a constructor for the class carton. So when I create an object, that's actually a carton class, it needs to call the constructor because every object has to call constructor. Then that particular construction of a carton object need to provide 4 arguments.
So, because earlier when you said you needed to start from the very top first,
right?
We don't have to do them one by one. We can just do them straight from carton. Like in this case, we don't have to create box first. And then...
So in this case, you see that the carton is actually going to call box. Okay, so it's actually called a parent. Let's look at the 3 class. Is the same thing. So let's look at holdable. So I have a holdable, which is a void. and look at the holdable implementation. Okay, you see that holdable over here, I didn't say which one to call. Why I didn't say nothing to call? Because I don't have argument to pass. Okay, thank you for your question. I forgot to mention, when I say this one, I said box, this three like this. This is not trying to mandate the order about which constructor to call. This is trying to mandate the argument I need to pass to the parent, okay? Because if you look at my holdable over here, the holdable does not have any kind of column or which classes beyond holdable is locatable. It doesn't actually explicit to call the locatable. It just say this is holdable. But it will actually call, because of the inheritance relationship, it will call locatable. And the locatable, this one, it will call the what do you call that? The MT3 thing also has a constructor over here. In this case, I make it very simple. So everything is a void. I didn't take any argument for the constructor, and therefore I don't need to put any of this argument column and then the constructor to the base class. Okay, you have a question? Okay. Okay, I hope you understand everything about this slide, except the mode of the inheritance, which is the public or whatever over here. But I want to use a different slide to represent this. So what I did was, I have a derived class, and then I have a base class. And you see that I have a constructor. So essentially what I did here is that when I try to call the constructor for the derived class, it will first go to the base class and finish the base class constructor before it actually come back to execute the derived class. Okay, so that is the way using this picture to mention. Okay, so now I'm actually going to talk about the mode of the construction. So now you see that all the stuff over here. So you have a parent class, you have a base class, and then you have a private protect public. You have so this child class, because I don't have any derived class, so I only put private and the public, right? Okay, so and then there is a mode about when you're inheriting, whether you're inheriting as a public, derived, or protected. Okay, so here is the chart that you need to learn, that how to put those modes. Okay, so when you inherit, you can inherit. So far we always inherit as public, but you could inherit as a protected, or you could inherit as private. But let's actually look at what does that mean when you inherit the public. If you inherit the public, if that particular attribute or member function was protected in the base class, then it will be protected in the child class. If it was public in the parent class, then it will be public in the child class. So essentially, public means that you not only inherit everything, but you inherit exactly the same kind of protection from the parent. So the parent is protected, you're protected. Parent is public, you're public. Okay, if it's, by the way, if parent is private, you cannot inherit. Okay, sorry, private is still private, I guess. Okay, why I didn't write that? Yeah, private is still private, I guess. Yeah. Okay, protected, public. But if you inherit as a protected mode, then your protected become private, your public become protected. So whatever is, if you inherit from the base class using protected, then if the parent is public, the child class becomes protected. Similarly, if you inherit as a private, then essentially everything becomes private for the child class. Okay, so that's basically the mode, how you can use the mode over here to determine how you can understand the assets of each of the variable. Okay, so now you ask, why do we introduce protected? Because with protected, you will be able to have a portion of the variable from the parent to be actually more usable by the derived class in a more protected way. Okay. Okay. This is what I suggest. For the first time inheritance programmer, try to think about public. Don't worry about protected and private. Okay. Think about public, because public is easier, because whatever you have in the parent, you have it in the child as well. That gives you kind of consistency about what's going on. Okay. Yeah.
So the base class can have any of those three modes in the class, or can only have one?
No, the base class doesn't specify the mode.
Oh.
The mode is specified when you inherit from something. So this is the mode. Okay, so when you go back, let's go back to make sure we understand this. So remember when I call class carton, when I inherit from box, the mode is public. That means the box is as a protected, it will be protected for me as well. Okay, so that's the mode. Mode is strictly is this particular place. No, actually, if it's okay, I haven't checked again, but if I remember correctly, if this is a public, if you have a box, which is the attribute is private, then essentially you cannot inherit. So essentially parent can prevent others from inheriting the private. Yeah, okay. If you want to be derivable, you have to put it in protected. Yeah. Okay, so now that I think that makes sense, because that's why I was confused for a moment. Because when I look at this, even if you do public, the private is actually not accessible by the derived class. You have to protect your private. Yeah. Yes, in the back. Yeah. In the private mode, the base class has either protected or public. It will become treated as private in the derived class. Does that make sense? Let me use an example. For example, let's go back here. Let's go back here. So this one is protected, right? And if I inherit this and change this to be private, which means that all three of them become private to this class. Let's change even more. If I change this to be public, assuming these three are public, if I inherit the box using the private mode, then all the three become private, which means that no other code can directly access to this object. Okay. You have a question? Yeah.
If you made language by box private and then you tried to call it like inheriting through the public mode, would it just not copy?
Not copy. Yeah. If it's a private, then yeah, it's you can. Yeah, you're right. Yeah. Okay, let me change this back because I want to make sure I don't confuse myself next time. Okay, so yeah, please.
Sorry about that. So what is the difference?
Okay, the difference between private and protected is that if I put, let me first explain, then use example. So if it's so when I say private protected from the base class perspective, that means if I put a private, meaning that is not only private to outside the code, but also private to the class try to derive from me. So essentially, the carton, as I think you just mentioned, if I put this private, then the carton does not even have a length, width, and height. Doesn't even have those three attributes. So which means that it's not desirable, right? Because I want the carton to have those three variables. So if I do protected, it's still outside code cannot access, but the derived class or child class can actually access that directly. That's the main difference. So protected only makes sense when we have an inheritance, yeah, as a base class. Okay. Any other question? No, this is all great question because inheritance, I mentioned to you, that's a hardest concept. I want to make sure that we're all clear about every single detail about inheritance. Okay. This is really important concept we're talking about. Any other question? And don't be shy. Okay, I mean you guys already pretty good to learn this in at least try to learn this in 3 months in a quarter. I remember I spent years of programming. I'm still kind of confused about some of the inheritance concept. Okay, so I know how difficult it is. Yes. Okay.
If I make another class, like after garden, and I derive from the parent class as a private version, so the third class will it not be able to access?
Yes. Okay, so let's use this as an example. If I have another class called I would say carton. What's a carton? I call Amazon box. Okay, I create another class called class Amazon, which is colon private carton. Okay, so that means everything that's actually from, let's actually go back to the mode. Okay, so here's the mode. So meaning that if the carton box has anything that's public or protected, that's going to be private for the Amazon box.
My question was, if I get something from the original, like the base case, which is the box.
Okay.
In the carton, we get something from the box and then store it as a private. So
let's try to use this example. It's probably easier. I like your question. I just want to make sure we understand this. Okay, so assuming the MT3 thing has a sequence number, right? And locatable has a location, 2 attribute. And now when you have a holdable, you have both of them, right? Okay, so now you want to be able to inherit those 2, but you want those 2 to be private for holdable. Is that right? I mean, we don't care how it was treated, but I want to be private. So what you can do is this. Okay, what you can do is this. In this case, remember here, how do I make sure things to be private? Is I better use the private mode. If I use a private mode, then anything that's protected and public will become private. Okay, so I can control. I'm the holdable, right? So let's look at the code. Let's look at the code and then we will see what's going on. So let's first look at MT3 thing. MT3 thing, you see that sequence number is public. Okay, and then locatable, the GPSDD is also public, right? So now, but both of them, the inheritance mode is public. Okay, so now to do what you like to do, which is an excellent question. I really like your question. I have to change this to be private. If I change this to be private, that means I inherit from my parents. And those two, because they're public, so I always inherit. But when you get down to holdable, because I use the private mode, then both of them will be private to any object that's actually in this mode. Okay. But I want to tell you something, which is I'm pretty sure I can break this rule very easily, but this is getting ugly part about inheritance. So have you ever heard about the term called casting? Ever heard about this term called casting? Okay, so some of you nod your head, some of you doesn't. So casting is essentially transform or convert a particular variable from one type to the other type. For example, I can casting an integer to become a pointer, or I casting give an example, a pointer to a character to a pointer to the other data structure. Okay, I can do this. This essentially casting is changing the type. Okay, now go back to your question. I could potentially cast the locatable to I can cast holdable. Assuming I have the code looks like this. It's a holdable, right? I can cast a holdable to a locatable. And then I can access that public. Okay, that is a messy part. Casting sometime. By the way, inheritance, casting, you will hear me say casting a lot, because inheritance, when we manage the inheritance hierarchy, we have to use casting. And the casting is very different in C, from C to C++. In C programming, if you do C programming, you do casting. For those of you who already done casting, you really just change the type and make the compiler just declare to the compiler that I know this is the type I want to deal with. For example, you convert from an integer to a pointer. Essentially, you just tell compiler, say, hey, I know what I'm doing. This is not a compiler error. This is not a type error. I just want to use this integer as a pointer. Okay, by the way, that itself is kind of really, really tricky. Why do you want to treat an integer as an address? That's only happened to C and C++. Okay, that's the casting. You just basically tell the compiler you know what you're doing when you're doing casting. And the value of that integer or the value of that address doesn't change. Okay, so when you do casting, you're not changing the value. You're just doing the type changes. But in C++, it's different. In C++, in many cases, when you do the casting, you not only change the type, but you also change the value itself. So that really confused a lot of C programmer when they first do C++. In fact, I mean, Java, Python, you never have to worry about casting. It's only C++. I will say, I think this is fair to say that casting is really, really difficult. Much, much easier in C, but really, really difficult in C++ when you do this kind of casting. We'll see a lot of examples. Okay, so let's try to summarize before I go back to your question about how do I override the parent. So this is the inheritance relationship. How do you declare inheritance? How do you specify the mode? And using that mode, you can actually control how to access different variable from the derived class. And I just remember I have to change this back. This is a public. Okay, for this picture, this particular size, any other question? Okay, let's think about a different issue right now. I want to now move to a different class. I don't want to talk about virtual function yet. Okay, let me use this as an example again. Let me use this example. Let's go back to the code itself. Okay, this is the directory that have all the code for the midterm number 3, holdable, locatable, and GPS location. So I'm going to declare a function. So the question was, well, how do I override a function, a member function that was declared by the base class? I want to have something different. Let's actually go to the GPS.h. Okay, so this is the ultimate base class. And in the base class, I'm going to declare a function. This function I call a foo. Maybe I just call this function void, foo, void. Okay, this is really a dummy function that doesn't take any argument, doesn't return anything, but it will print out a statement. I will say standard cout, and I will print I am a MT3. I am a MT3, and then I'm going to put \n. Maybe I just use C++ style. Now you see I'm using cout, okay, and the end line. I'm using essentially a C++ style doing printf. This is called cout and also end line. So I have a function called foo, which is a void std cout. I'm a MT3, okay? So I create a function looks like this. All right, so now I'm actually looking at the derived class, which is locatable.h. So locatable.h, you can see that I'm inheriting public mode from MT3 thing, and I do not have that function foo, but I want to override that function. So how do I do that? I just basically redefine this. Go over here. I actually copy everything. See, the function signature is the same. I say I am a locatable. Okay, so you can see that this two function, they are the same function signature, but one defined in the base class, one defined in the derived class. And I just redefine that class with the same function signature. So now I have a different behavior. And I can do the same thing for holdable.h. And it's the same thing. I actually have another function. Say I am holdable. Okay, so now I have the 3 function, but I have a 3 different level. Each of the class hierarchy, inheritance hierarchy, I have a different version for the same function too. Okay, so in this way, I hope you understand. I already override so let's try to run this program, see how it works. Yes. Let me run this program test. Let me see my make file first. The make file, the default is MT. Okay, test MD3. It should be test MP3. Yeah, test MT3. Okay, good. So this is the test program. You can see that I create, why have a label GPS? Okay, anyway, don't worry, label GPS. I actually create a holdable item and MT3. Okay, I'm going to just create a. Okay, so let me tell you what I did. I create an object called holdable, and then I actually make a pointer. So a holdable object is item 1. And then the parent class, you see that here, I actually assign the address of item 1 into a pointer to the MT3 thing. So let me go back to what I'm doing in the inheritance hierarchy. So essentially what I'm saying is I create an object from holdable, and I actually casting the pointer to the MT3 thing. So I'm actually moving the object from the type of holdable to MT3 thing. Okay. All right. And this is a little bit abstract, but this is part of the code, holdable. But then what I'm going to do is this. I'm going to return from here. Okay. So I don't have to run the rest of the stuff. So now I'm going to do item 1.foo. That's my current version. But then I'm going to run MT3 PTR to the foo. Okay, I'm going to first run the program and then just explain those two. What's the difference? They're actually from the same object, but with casting. Okay, so let me try to compile it. I think it's make test MT3. What happened? What? I thought I already did. Foo. Oh, I already have a foo in one of the GPS.h. Sorry about that. Emacs. What? What did I do? Let me don't call it foo. Call it something else. I might have messed up with some of the stuff. Oh, you know what? Sorry. Thing.h. I made a mistake, sorry. Foo stardust.h. Where did I do that? GPS? Oh, it's GPS.h. Sorry about that. I have to change the GPS.h. No, I make the mistake. I shouldn't put it here in the GPS. I should change it to MT3 thing. .h. Yes, that's the right place. I make a mistake. It's my bad. Okay, let's try to run it. Okay, so I haven't run this program, and let's try test MT3. So you see that the first line it prints saying that I'm holdable. The second line it prints saying that I'm MT3. So what's the difference between these two? So let's take a look at the test program. What did I roll? Okay, this is the program I wrote. And forget about GPS and label GPS. Okay, label GPS is just another derived class from GPS. I don't want to complicate here. But essentially, I create a person and I create a holdable item. I set the holdable item to be the person, the GPS location, and whatever the sequence number for that item was. So what's the class of item one? Item one is a holdable. So if I do control X2, escape X, shell, if I run that test, NT3, you can see that the first line I print, I'm a holdable, and the second line I print is I'm MT3. Why is that? Because the first line, I actually declare an object called holdable, which is item one. And then when I say item one dot foo is going to print I'm a holdable. So it's the same object. But then look at what I did here. I do a casting. Essentially, I put the address of item one into an address of another class, NT3 thing, which means I change the type from the derived class, from the grandchild to the grandparent. And then essentially it basically convert himself believe that I'm actually an MT3 pointer. And then therefore when I try to print it, it will go to IN a MT3. Okay. Okay, so now I'm going to do one more trick. I haven't actually really done this, but I'm going to do this anyway. Can I do this? I might be able to do this. Let me try to do this. I'm actually going to cast it back. I would say holdable star. If I do casting, I actually have the MT3 pointer and I casting with holdable. So I'm actually, instead of going up, I'm actually going down. So I'm putting here. What do you think this piece of code will give you? Number one, I will get a syntax error. Number two, it will print I'm holdable. Number three, it will print I'm MT3. If I do this, which one do you think I will get? How many of you think I'm going to get a syntax error for this? How many of you believe it should print I'm holdable? Some of you. How many of you think that I don't care? You're talking about. Okay, don't worry. All right. So the rest of you think that I should print I'm MT3, right? Okay, let's try. I might get an error. Oh, it's not syntax error. Good. You see, it casting back. Okay, so I have a holdable. I move it to an MT3 pointer, it go up. Actually, when I call foo, the same function will call that version. But then when I push down, I by the way, if you have a parent class, if you have a derived class, even in this case, it's actually magical. If you think about this, I have this hierarchy. If I have a pointer, that's actually pointing to an MT3 thing object, which is a base class, base. It's not just first base, but it's 2 level up. I can casting to an object, which is a grandchild of that object, and then it will behave as a grandchild. Okay, this is actually pretty difficult if you think about that. I mean, if I move up, it thinks that, well, because this one inherit everything from the parent, to move up is easy. But by the way, the C++ as a language, it allows you to move down as well. It's move up and move down allow you to control a lot of things about the behavior of the object. Depending on how you casting, how you place your object pointer or object presence or reference in the hierarchy, your object is going to behave differently. Yes.
And even though the pointer is of class MT3 thing, you can still access the elements in
Right. That's right. So that's why I think I forgot her name. Her earlier question is if I do private, if I casting, I can still access. Let me do okay. Let me do one more evil thing, okay, to just impress you before we go. So I can do this even for this. I really like this example. It might be syntax error as well. But assuming I create a class called MT3 thing. Let's say I create something called MT3 thing. I call MT3 item 2, okay? Assuming I create MT3 item 2, it's an MT3 thing. And then I can still do this. I can still do holdable star. Let me still do holdable star. And then I put MT3 thing, MT3 item. Okay. Take a look at what I did. What I did here is I actually look at the object that's originally created by MT3 thing. It was not holdable. It was created by MT3 thing. And then I try to call through. Does that make sense? It doesn't make sense, but C++ language allow you to do that. So what do you think this line is going to print out for us? It's going to print out holdable, I guess. I mean, maybe error. Let's see if I get a compiler error. No, it doesn't give me a compiler error. And I run it. Yeah, it says I'm holdable. Even the object that was not created for holdable it's never a holdable object, but I can make it a holdable object. This is how evil the language is, just to let you know. You can mess up a lot. I mean, by the way, Java, Python, this is impossible. Okay, only C++. All right. All right, that's why I should stop here. I will continue this topic, okay?